Example 6. Write an equation for the inverse function for the one-to-one function defined by f of x is equal to x minus 2 divided by x plus 2. All right, following our procedures, we're going to take the f of x out and replace it with a y. So this function becomes y is equal to x minus 2 divided by x plus 2. All right, the next thing we want to do is interchange the positions of the x's and the y's. So we have x is equal to y minus 2 divided by y plus 2. And now we want to solve this problem for y. So let's put a 1 underneath the x here so that we can cross multiply. And we're going to have 1 times y minus 2 over here on this side. And then we're going to have y plus 2 times x on this side of the equal sign. All right, and let's distribute on both sides to get rid of the parentheses. This is going to give us y minus 2 is equal to xy plus 2x. All right, now we're solving this problem for y, so we should get all of the y's on one side of the equation. So let's subtract the xy over here. Now, when we do, none of these are like terms. And so our problem now becomes y minus 2 minus xy is equal to 2x. Now over here I notice the 2 is the only thing that doesn't have a y attached to it. So now I'm going to add this 2 over here on this side. That's going to leave me with a y minus xy over here. On the other side, these are not like terms, so we just have 2x plus 2. All right, now I have two terms here that both have a y in them. So I'm going to employ a little trick, and I'm going to pull out the greatest common factor. You see, both of them have a y in common. And if I factor that out, I'm going to be left with 1 minus x. And then this will still be equal to 2x plus 2 over here. And then to get y alone, now all I need to do is divide by the parentheses there, the 1 minus x. So y is going to be equal to 2x plus 2 divided by 1 minus x. And when I replace that y with its function notation, the inverse function becomes f inverse of x is equal to 2x plus 2 divided by 1 minus x.